Okay, welcome to our video on properties of logarithms. Remember years ago when you learned how to add, subtract, multiply, and divide, and you did that with whole numbers, and you did it with decimals and fractions, and lots of different kinds of number systems. We need to be able to do the same kind of thing with logarithms. So the purpose of today's video is to talk about those properties and talk about some of those operations that we do with logarithms. Okay, so we'll look at sum, product, and difference of logs. We'll look at expressing things as a single logarithm, evaluating logs, and simplifying. Okay, so first off, just as a quick review, remember doing add, subtract, multiply, divide, those kind of laws with exponents. We learned that there's a product law. When you multiply common bases, add their exponents. So this one would be x to the fifth. Dividing common bases, subtract their exponents. So this would be x to the minus 2 or 1 over x squared. The power law, if I have an exponent, I'm raising the whole thing to another exponent, I multiply those two. So that'd be x to the 15th. This is one law that you may not have looked at a whole lot before, but it's one that's fairly powerful in exponents, especially solving exponential equations. And it says that if you have the same base, that the exponents must be the same. Here I don't have the same base, but maybe I could get that, because I know that 8 is 2 cubed, and I know that 16 is 2 to the fourth. And here I have a power law, and so I can write that as 2 to the 3x is equal to 2 to the fourth. Now I can use the same base law that says if the bases are the same, the exponents must be the same or must be equal. And then solve that equation, 4/3. So these are some fairly powerful and hopefully familiar laws that we've looked at exponents. With logarithms, we have similar laws, and here they are. We have a product rule or product law that says if I'm taking the logarithm of a product, simply log the first, log the second, and add the results. Quotient rule, same kind of idea. If I'm taking the logarithm of a quotient, log the first, log the second, and this time subtract the results. I have a power rule, which is probably the most different one that you'll see. And what it says is if I'm taking the logarithm of some kind of value that has an exponent in it, I can pop that exponent out to the front and multiply it like I've done here. So it's p times the log base a of m. That's a fairly powerful rule that we'll see later in solving logarithmic equations is very useful. Other sort of miscellaneous logarithm properties would be this one. If I'm taking the log base a, and if a is the base of my value here, then the result of this whole expression is simply x. It also makes sense when you read this as a logarithm. To what exponent is a raised in this expression? It's raised to the x. So that's the answer. Also, to what exponent must I raise a to get 1? If ever I have a 1 here, it doesn't matter what the base is. If I have log with a star base and there's a 1 here, to what exponent must I raise this to get a 1? It's always 0. So it doesn't matter what the base is. So let's try we'll go through each one of the rules individually. So the product law, taking the logarithm of a product, log each one at. Okay. So here I'm taking the logarithm base 2 of the product of 4 and 5. So I can rewrite that as the log base 2 of 4 plus the log base 2 of 5. Because it's a product, I take the log of each one separately and add the results. Now this one I can simplify further because to what exponent must I raise 2 to get 4? That's 2. I can't do the same thing here because this one doesn't come out bang on. I could, if I wanted to, figure out what this actually is with the change of base formula down to a decimal. It'll be 2 point something or other. So I could do that, or I could leave it at this point. Here's another one with the natural log. So it's a product here, so I log the first, log the second, and add the results. Recall that ln is the same thing as log base e. So if ln is log base e of e, this is saying to what exponent must I raise e to get e? Well, the exponent up here, since there's none indicated, we assume it to be a 1. So the whole value of this part is simply a 1. So I'd have ln 3 plus 1. Again, I could figure out ln 3 on my calculator. It'll be 1 point something or other plus 1, and I could add those together to get a decimal answer. Or I could simply leave it at this point here. So that's product law. Quotient law, same thing. I have a quotient, I'm taking the logarithm of a quotient, so I log base 5 the first one, log base 5 the second one, and subtract the results. Which one of these can I simplify further? I guess this one I could use change of base formula and come up with a number. But this one, as you've probably correctly identified, to what exponent must I raise 5 to get 25? Answer, that's 2. Minus log base 5 of 3. So I could leave it at this point, or like I said, get a decimal equivalent for that. Same thing here. Now here on the top I have a product, and on the bottom I have 10. Number of ways I could do this. I could ln this plus ln of e minus the ln of 10. Or I noticed that in this fraction I could simplify that. That's the same thing as ln of e over 2. Just simplifying the fraction. Now I can apply the quotient law of logarithms, which says I ln the numerator, I ln the denominator, subtract the results. Ln base e, we've seen on the other slide in the product law that ln of e is simply 1 minus the ln of 2. So I could leave it like this or get the decimal equivalent of that because I have ln on my calculator. I just type ln 2. Okay, so that's a quotient law. On to the power rule. This one, like I said, I really like this one. So here, the question says log base 5 of 25 squared. A number of ways I could do this. I could figure out what 25 squared is. Let's do that. 25 squared, I believe, is 625. And then, to what exponent must I raise 5 to get 625? I think the answer to that is simply 4. Or I could do it this way using the power rule. This 2, since it's an exponent, I can move that out front. So this becomes 2 times log base 5 of 25. But what is log base 5 of 25? To what exponent must I raise 5 to get 25? Answer, that's just 2. So I have 2 times 2, which is equal to 4. Same answers I got doing it the other way. This one just was a little bit easier because I didn't have to know what 25 times 25 was. Here's another one. Ln base e of x. If I bring x out to the front, I'll get x times the ln of e. And we've seen twice already that the ln of e is simply 1. So the value of this expression simplified is x. That's a power rule. And in the next video, we'll show you how powerful the power rule is. Okay, putting some of these properties together, here I see a question that says expressed as a sum and difference of logs. So log base a of, here I have a product. So I can use my product rule because it's x cubed times y squared times z. So I'll have log base a of x cubed plus log base a of y squared plus log base a of z. Now, I probably could leave it like this, but I also see these exponents up here for the first two, and I can use the power rule and move those out to the front. So log base a of x plus 2 log base a of y plus the last one I don't have to change at all. This is how I would write that as a sum and difference of logs. Here's another one. Ln of the cube root of 5x to the 5th. Okay, this cube root thing bothers me a little bit until I realize that, oh, I can just simply write that as a fractional exponent. Cube root would be 1/3. Oh, I could use a power rule and move that out front. So this would be 1/3 times ln of 5x to the 5th. Following that further, because this is a product, I could write this as 1/3. Now it's 1/3 times all of this. So if I break this up into the product rule, I'll need to make sure I put everything that's there in brackets. So this would be ln 5 plus ln x to the 5th, which you're probably already saying can be ln 5 plus, I can use the power rule here to call it 5 ln x. And that would be how I would express that as a sum and difference of logarithms. Again, there's other ways that I could have done that. I could have applied this 1/3 to the 5 and to the x to the 5th right off the bat and then broken it up. You'd find that you'd get something that's very similar though. Okay, now here's another one. Express this as one logarithm. Okay, so this is going back the other way. So I have it split apart and I have to put them back together. Well, I notice I'm taking the logarithm of this and the logarithm of this, and the operation in between is a minus. This must be the quotient law. So in applying the quotient law, I can, in putting these together, I can just say it's the ln of both of them. But when I put them together, since this is a minus, it's the quotient law, it's going to be the quotient of x squared minus 9 over x minus 3. You can put that in brackets or you don't have to. Oh, now x squared minus 9, isn't that a difference of squares? I could change that to x minus 3x plus 3. Ooh, this is going to work out just beautifully. And I have an x minus 3 on the bottom. This one will cancel with this one, and I'll be left with the ln of x plus 3. Notice that I put the brackets around there because this is not the same thing as ln of x plus 3. In this case, I'm taking the ln of the sum of these two. Over here, I'm taking the ln of x, finding out the answer to that, and then adding 3. The two are quite a bit different. Also notice that I'm taking the ln here of a sum. So I can't apply any of the rules that we've looked at so far. We've looked at a product rule, so taking the ln of a product, that's not what I have here. And the ln of a quotient, again, not what I have here. So this would be the end. That's where I would stop. So the things we looked at today then are some properties of logarithms. We've looked at the product rule, the quotient rule, the power rule, and a few miscellaneous rules. We'll use these rules in helping us when we look to solve logarithmic equations.